Welcome to the lecture number 28 in the course on noise control in mechanical systems with myself Professor Sneha Singh, and in this lecture we will begin a new module which is the module on noise control principles or the principles of noise control. So far we have covered various modules. We introduced this course and sound and noise, then we introduced some acoustic fundamentals. Then we studied about sound signal analysis, various spectral analysis, time domain analysis and so on, octave band analysis. Then we studied about the human response to noise, because noise itself is a subjective perception. So, human response to noise, and then we studied about noise measurement and instrumentation. Okay. So, now we will study the principles of noise control. So, we will study about the source path receiver model, then the various categories of noise control like active and passive, briefly I will introduce, and then the integrated approach to low noise design. So, let us see first the source path receiver model. So, in general a typical noise control strategy or the principle of the noise control can be described by this model which is called the source path receiver model. So, what it means is that let us say there is some noise source and we want to remove or we want to reduce the noise. So, the source is there, then from the source the noise is being created. This noise is then radiating either through some structures or through air or various other pathways, and then through those pathways it is reaching the receiver where the noise has to be controlled, the receiver which does not like that sound and would like to control it. So, we have a source and then from which the noise is generating, some path through which it is travelling, and then finally the receiver or the person who wants to reduce it. So, that means that the noise control can either be achieved by either modification of the noise source, modification of the noise path, or the modification done at the noise receiver. These are the three scopes where which it can be done. And typically for a noise control engineer, the strategy is like this, that you always give preference to source modification. Okay, that gets the highest order of preference, and when source modification is not achievable or out of your scope, then you go for the path modification. Okay, and once path modification in some ways is either not effective or somehow it is not feasible or costly, then finally you try for receiver modification. So, that is the preference order. You always first try to modify the source, if not possible then path, then not possible then receiver. So, what are the things through which noise source can be modified? The first thing could be you replace the power source with a quieter one. Let us say for example, we have a combustion engine vehicle. Okay, it makes a lot of noise, and the engine being one of the major source of the noise within the vehicle, you replace the engine with a quiet electric motor or batteries, right. So, you get electric vehicles, fuel cell vehicles like that, and you know that these electric vehicles, the fuel cell vehicles, these are much quieter than the IC engine vehicles. Okay. So, here what happens, we have modified the power source. Okay, whatever was the source that was creating the power, due to certain mechanism it was generating more noise. Now, it has been replaced with a more quieter way of generating the power for that machinery. The other could be replacing the old machinery with a new one. So, you see that with time what happens when you have a new machinery, it usually functions very smoothly. You have better lubrication, smoother parts, surface finish is better, and all the parts are properly installed and tightened. But with time and usage of the machinery, slowly it starts to degrade, the corrosion happens on the machinery parts and the surface harshness comes in. Then some parts get loosened up, and then as the machinery gets older, it starts producing more noise. So, most of the times it happens in machineries. So, once the machinery is too old and very noisy, if you replace it with a new machinery, then the noise levels are going to go down. So, again this is one form of modifying the source. Okay. Then suppose you have some machinery component, usually the noise is created when two parts are impacting together. Okay. In a machinery, it could be the meshing of the gear or the bearings. So, whenever two parts are contacting or meshing with each other, then it creates a lot of noise. So, if you provide a better lubrication, then that impacting between the two rigid bodies is smoother, and the surface whatever the noise is generated due to the surface harshness or the surface roughness between the two impacting bodies, that gets reduced with better lubrication. So, that also improves the sound. So, let us say for example, I am riding my vehicle. So, you know that new cars, they have, from the sound of the car itself, I can know what is the condition of the running car. So, sometimes as if the car is not properly lubricated, the engine oil is not there, etc. After a point in time, it creates weird noise. Once the parts have more friction and abrasion between them. You give the proper lubrication to these vehicles and cars, and then you will see that suddenly the sound quality has improved, the sound level has slightly gone down. Okay, so lubrication of these impacting or colliding parts which are creating the noise, that also will reduce the noise level. Sometimes there could be manufacturing defects in the machinery. So, maybe during the design stage, when the designer designed the machinery, they balanced all the forces acting on the machinery, and accordingly the various components were designed. But due to some manufacturing defect or due to just the corrosion of the machinery over a long term usage, some kind of unbalance has resulted because of some unbalance in the masses and stiffness, etc., and some kind of eccentricity in the shape of the part. Due to this also it creates unnecessary vibration, because when we are designing a machinery, we are balancing all the forces so that minimum, the machinery is working with minimum force. But due to this unbalance or eccentricity that may result, there could be an additional force that comes in, and due to this acting of this force, it vibrates the machinery. So, the vibration of the machinery part increases, which ultimately increases the sound level coming out of the machinery. And various other causes of vibration that may be happening in the machinery can also be removed. You can choose the quietest machine source available in a factory setup. You can reduce the force amplitudes, because if you reduce the amount of forces acting in the machinery, you would get a quieter machinery. And how do you do that? This is achieved at the design stage. Once you are designing a new machinery to serve a particular purpose, you look at what are the operating conditions, what it has to perform, and what are the typical loadings that the machinery is going to be subjected to. So, if by some way you are designing and you are able to balance the loading, or the way this force is acting, you are able to reduce the amplitudes of the force by sort of modifying the machinery part and modifying the point of contact of the forces, then you are able to reduce the forces that may be acting on the machinery while it is able to achieve the same functionality, then you would be designing a quieter machine. Similarly, there could be some way through which, even if the forces, you cannot reduce the magnitude of the forces acting, you can make sure that the force do not act instantly. So, there is no sudden impact between the bodies, but there is a slow application of the force. Okay. So, for example, let us say the bevel gears used in any kind of machinery are quieter than the spur gears that are used. So, what happens in the bevel gears, the way these the gear teeths are, usually when two gear teeths mesh, you have this spiral kind of an arrangement, this bevel gear, two bevel gears meshing, and in the spur gears you have this vertical gear teeths. So, when they come together, okay, this is how the meshing is. So, when the two teeths are meshing up, they are all at once the contact is happening with the entire tooth, and the forces, they are sudden application of the force. So, the spur gears in general are quite louder, whereas you have the bevel gears, they are achieving the same kind of power transmission as the spur gears, but with the same functionality, because the teeth are meshing slowly as the gear rotates, not all at a time. So, due to that, the vibration induced is less, and hence they are quieter. Okay. Then softer materials can be used for the impacting surfaces. Okay, so whenever you have a machinery, you have two or more parts, they are colliding together, and some parts which are impacting, which is creating a lot of noise. So you can use softer materials, provided it's able to achieve the same functionality. You can balance the various parts to see that there is no excess force in the machinery. This again also is done at the design stage of the machinery, where it is designed to have least amount of excess force. Better lubrication I have already covered, and then improving the bearing alignment. Usually bearing forces are one of the bearing forces in most of these rotating machineries. They are a major cause of vibration, which then lead to noise. Okay. So, if the bearing is properly aligned, then the forces acting on these bearings, there is again, the forces are getting balanced and excess force is not there, and the vibrations can be reduced. So, these are all the methods in which what we are doing is, we are sort of in the machinery itself, we are doing the modification that it becomes quieter. In the same way, you can use, if the vibration is a major part of noise generation, you can use dynamic absorbers that can absorb these vibrations. You can use the vibration isolators. You can make sure that the natural frequencies of the machinery elements are different from the operational frequencies, because you do not want the resonance to set up, okay, because then the vibrations amplitudes are going to increase. So, the natural frequencies should never be equal to or even near to the operational frequencies of the machinery. You can add dampers to dampen the vibration amplitude. You can isolate using various vibration isolators, so that from the machinery to the path, the vibration gets isolated and does not transmit. You can reduce the radiating surface area. So, there are many times you have machineries which have large panels, okay, and the machinery starts, whatever is the mechanism of power generation, due to which the lot of vibration is set up, and this vibration then transmits to the panels of the machineries, and these panels then radiate the sound forward. We have discussed about radiation from these panels, okay, how the panels radiate. So, the panels can be designed in such a way that you reduce their surface area, because per unit surface area a certain amount of acoustic energy is being radiated. So, suppose you can add holes or some way, so that the structural integrity of the panel is maintained while the surface area is reduced, then you can reduce the radiation. In the lectures on radiation through infinite panel, one method was discussed, is that where you can play with the incident frequency, okay. So, whatever is the critical frequency, that below the critical frequency there is no radiation. So, you can make sure that the critical frequency of the panels is much higher than whatever are the operational or external frequencies that may excite these panels. Then also you can reduce the radiation of sound from these panels. And then you can operate the machineries by giving not continuously but with breaks, that can also improve the performance and bring the noise level down. Now, what are the methods of modifications in the noise path of the machinery? You can see, so the machinery can transmit, before that let us see what are the noise paths, okay. So, usually the noise can transmit from the source of the machinery to the receiver by either through the structure, the solid structures, or through the fluid medium, which is the air. So, we can have structure borne noise and the airborne noise. Okay. So, whenever what happens, noise is transmitting from the source, traveling through these structures and ultimately radiating into the air to reach the receiver, that is usually structure borne noise. For example, let us say I have some kind of heavy machinery which is vibrating and I keep it directly on the floor, or I keep it on a stand and the stand itself vibrates. So, let us say for example, I have a big loudspeaker. Instead of suspending it in the air via some technique, I am keeping it on the hard surface. Okay. So, here what happens is that the speaker is vibrating, now it is coming in contact with a hard surface which is the stand of the speaker. Then the stand itself starts vibrating. So, what happens that the vibrations from the source, which is the speaker, is now transmitting to these stands. So, here it is a structure borne sounds. Okay. The sound is first transmitting through these stands and then going through the floors and the walls and finally multiplying many folds and then finally radiating onto the air and reaching the receiver. Okay. In the same way, you can have the other pathway could be directly, from the source the noise is directly emitting into the air and traveling to reach the receiver. And based on whether the noise is reaching the receiver via structures or via air, you have different path modification techniques for the two type of noise pathways. Okay. So, suppose it is an airborne sound. Okay. If this is for airborne, you can install barriers which are materials that reduce the transmission of noise. So, let us say this is your source, okay, this is your receiver, okay, and the sound is transmitting through. Okay. Suppose you put some hard material which stops the sound wave from propagating. Okay. It is a high impedance medium. Okay. It is stopping and blocking the sound waves, reflecting most of it that is coming by. It is going to attenuate the sound at the speaker. So, you can install such barrier materials, or in other way, suppose it is a closed room, you have a machinery source or some kind of source and these are hard reflecting surfaces of the room, and you have some listener here or some receiver. So, the sound is reaching directly from the source to the receiver, whereas the sound is emanating in all the directions. Okay. So, because of reflections, it is reflecting back to the receiver through these various pathways. So, the direct sound is getting multiplied because of these reflected waves that are coming. So, in such kind of confined environment where the reflections are quite significant, if you install some absorbers which stop these reflections. Okay. So, basically you do certain treatment on these walls so that they simply absorb these sounds. So, these reflections are stopped. Then also the noise level can be brought down. So, these are like modifications in the pathway in which the noise is traveling. Okay. So, some techniques, some individual techniques. So, let us see what happens. So, I will try to categorize it as structure borne and airborne. So, for example, structure borne here, this is like structure borne, this is for structure borne noise, because it is transmitting through the structures in the form of vibrations induced in the structure. You can use vibration isolators, and for airborne let me use a different color coding. So, for airborne I am using green color coding, and for structure borne I am using red. Okay. So, similarly installation of the enclosures, it's for the airborne sound. Okay. Absorbing materials again like in the previous case, here it's for the airborne sound. Use of reactive and dissipative mufflers, again this is for the airborne sound. Using vibration breaks in the ducts. So, many times ducts and pipelines, they are a source of radiation of noise. If you stop, instead of having a continuous ductwork of pipe, you just have interconnection between these pipes. Okay. So, you interconnect the various pipes, or you include some kind of isolations or some kind of dampers in between the different at different distances in the pipes. So, you are sort of trying to break the vibration path. Okay. So, you are trying to break the vibration path or the path through which the structure borne sound is travelling through these ductworks. Then mismatch in the impedance of the materials again will help in transmitting the noise from one part of the material to the other part. Lining of the ducts, use of plenum chambers, flexible ductwork, all of this will stop the structure borne noise. Similarly, finally, if suppose source and path modification is not possible, you want to control the noise at the receiver, then what you do is simply provide ear plugs or ear mufflers to the personnel who has to be protected. You can construct some particular acoustic enclosure. So, suppose this is some machinery source, this is your personnel and a lot of noise is being generated by this machinery source. So, you can enclose it in the thick barrier material enclosures, so that some form of sound is attenuated while passing into the enclosures. Okay. So, it is sort of reflecting these sounds so that it does not reach. So, they can be isolated. If suppose in a factory setup you have various workers and they have to work on the heavy machinery, you can rotate the workers so that not all the workers they are within the permissible noise dose limit. So, you can do the rotations of the worker in the machinery, heavy machinery, or you can simply make a factory setup such that all the machineries they are operating in a single room and the personnel room is quite further away from these machinery sources. Okay. So, when you begin as a noise control engineer to try to apply, so these are some of the options you have with you, what you can do for the receiver, what you can do for the path, what you can do for the source. So, various options are there and more, but how to choose which option to apply for a particular case at hand, for that to begin with you can do noise source or path identification and characterization. So, what it means is that in order to determine, because you can't do everything. Okay. So, when you have some kind of noisy environment, there are plenty options to do to reduce the noise, but because of the resource constraint, the time constraint and the money constraint, you cannot apply all these procedures. So, you have to prioritize which one will suit my case the best. So, for that what helps you in prioritizing and choosing the best options is that you first identify which are the most dominant noise sources. So, there are various noise source identification techniques. They are not part of this course, but if you are curious you can go and read about it. There are various kind of techniques like beam forming, holography and localization techniques. So, through those techniques we are measuring and trying to identify which are the most dominant noise sources. Suppose you have some kind of a setup where you have so many machineries, you can identify that this is the most dominant noise source, followed by this and this, like that, and you can rank them. So, rank 1, 2 and so on. Okay. And your treatment should always begin with the most dominant noise source before you move on to the second one. So, in case you have more resource and time and money left, then you can move on to the next one and so on, but priority should start with the most dominant noise source, because that once that is quietened, that will be the most effective. Then in the same way, just like you sort of identify and rank the noise sources, you can do the same thing for the pathways as well. You identify what are the various paths through which this noise is reaching the receiver, and then you try to find out what are the most dominant pathways and you rank them. Okay. You rank the various paths. Okay. So, from this path the maximum transmission is happening, followed by this path and so on. So, you can use the techniques such as transfer path analysis and so on, and based on that you begin with the treatment of the most dominant path and then the next one and so on, given that you have additional resources left. In the same way you can also characterize these paths. Okay. So, once you are trying to identify and rank the paths, you can also find whether it is a airborne part, whether it is a structure borne part, how much of structure borne and how much of airborne is happening, and accordingly you can decide the treatment. So, let us say some examples. So, let us say for example, we have some machinery which is installed in these mounts. So, this is some kind of mount or stand for the machinery on which it is set, and then this is the ground, and we have the receiver somewhere here. Okay. So, firstly I can see, I can do the noise. Suppose here I only have one machinery. So, I see that okay, this is the most dominant machinery, there are no multiple machineries here. So, I can directly begin and see what are the dominant paths. So, I can use the technique called as transfer path analysis, again something which is not part of the course, but it is a technique through which I find out the contribution of the different pathways. So, I can find out I can install microphones at these various identified paths at various locations. So, I can install accelerometers here, I can install my, so these are the various sensors. So, I can have sensors to measure the force amplitudes and the pressure amplitudes, and based on the data I can find out which pathway is the most significant one, and on that pathway, if it is a structure borne pathway, I can put isolators and damping materials. If it is airborne, then I can install barriers along that pathway, and so on. In the same way, suppose I have a setting where we have a big factory. Suppose we have machine A, machine B, machine C, and some receiver here. Okay. So, here again I can do the noise source identification. I can do something called as sound mapping, which maps or gives me an image of the sound field in this area, from which I can know which machinery is creating the most noise, as well as which part of that machinery is radiating the most noise. So, suppose I find out that okay, this particular portion of the machinery is having the most dominant noise emission. So, my treatment can begin at that particular point, and then you identify if suppose these machineries are mounted on certain mounts. So, you identified that this particular panel or structure is creating the most noise. So, what is this panel connected to? Whether there is a strand or a structure that is connecting these panels and the noise is forwarding. So, followed by sound mapping and noise source identification, you can do the transfer path analysis to find out what are the ways through which it is reaching the receiver, whether it is reaching it directly or whether it is reflecting back and receiving, or through the structures it is going, and then you treat. So, you treat the dominant source component using appropriate technique, and then you treat the path, because source modification will take a priority. So, you first begin by treating that source itself, provided you are allowed to and it is not hampering the functioning of the machine, and once that is done, then you can forward and try to modify the path based on whether it is structure borne or airborne. Okay. So, if airborne, some airborne techniques will be used. If it is structure borne, then structure borne techniques will be used for path modification. Okay. Most of the times what happens is that the noise control engineers, they are called once the problem is persisting. So, there is some noise that is in some kind of industrial setup or machinery environment, you have a lot of noise, and then some noise control engineer is being called. So, there the machinery is already installed, everything is in place, and then the engineer is called. So, the engineers, the noise control engineers' hands are tied down, they cannot change the machinery because they are not allowed to do whatever. So, they are only left with modification of the path. So, that is why majority of the noise control techniques, they cater to noise path modification. This is some of the recommended noise control strategy based on the source path receiver model. So, suppose a general noise level has to be reduced, then source can be quietened, isolation and damping can be done to structure borne absorption at the airborne, and so on. If some extraneous noise is there which is intruding into this, then you have these barriers and enclosures to close the noise, as well as some kind of masking you can provide. And suppose many people have to be protected from some noise level, some personal protection can be implemented. Okay. Suppose many distributed sources are there, you can go on do the noise source identification, quiet the dominant source, use these barriers, enclosures, isolators and personal protection and so on. For localized sources again personal protection can be done, barriers, isolators and source quietening. Few persons and many distributed sources at damaging levels, sometimes these are more effective. When it is a reverberant environment with lot of echoes, flutters and reverberations, then you can use absorber as the most effective technique and so on. Okay. So, now we know that there are various ways through which the noise can be controlled, source path and receiver modification. So, now these various path based noise control techniques are divided as active noise control and passive noise control. So, we will study about the active noise control from the next lecture onwards, and then we will continue with a detailed description of the passive noise control. So, here I will just briefly introduce this idea. So, in the active noise control some secondary sound is added antiphase with the target sound to cancel out the overall effect. Okay. Whereas, in the passive noise control we do not add additional sounds, rather we add the various materials to block or absorb the sounds. Okay. And the advantages and the disadvantages are that ANC can be used for low frequency more effectively. It is more effective for low frequency, whereas passive noise control techniques, they are very difficult for low frequency. Okay. So, low frequency is a challenge for PNC, whereas ANC achieves that. They are in general more effective because you are introducing a secondary source which is ideally trying to completely cancel the sound that is present in the fluid medium. So, definitely it goes to ideally 0. So, this is the more effective compared to the passive noise control technique. However, this depends on various kind of electronics and circuitry, whereas there are no complicated electronics and circuitry is required. So, this is a negative point here, and here the control is non-uniform across space. So, depending on where your electronic circuits are, you are taking your microphones, you are trying to produce the noise through the speakers, and then this noise is trying to cancel the other noise. So, the effect is very dependent on the space, it is very non-uniformly distributed, whereas in this case there is a uniform effect. This is more costly and this is less costly. So, we will study about all of this from the next lecture onwards. And finally, I would like to close this lecture by saying that noise control engineering is essentially becoming an integral part of any kind of manufacturing and machinery design stage. So, suppose you have any company or any product that is being made or machinery that is being made. So, you usually have these design team, engineering team and the materials manufacturing team that they work together. They work in a very collaborative environment to come up with a foolproof design and manufacture that particular machinery effectively. Then you have they also collaborate with the finance team together so that the cost of developing the machinery can be minimized as much as possible to increase the sales and profitability, and the sales and marketing team and the customer relationships team ensure that the product is saleable and there is a demand for it and people are attracted to it, and a lot of such machinery products can be sold. So, this is an essentially a setup in any kind of supply chain or design, manufacture and the sale of any kind of machinery. So, noise control engineers also are finding a place in this particular setup, and they also have their own there has to be an integrated approach or more collaborative approach. People cannot work in isolation, so they need the data from all the different clusters in a typical setup. So, with this I would like to close the lecture. Thank you.